At 12,800 feet above sea level, on a windswept plateau near the shore of Lake Titicaca in Bolivia, sits a scattered pile of stone blocks that does not make sense. It has never made sense. For 120 years, archaeologists have walked across this site, examined these blocks, and left with more questions than they came in with. The blocks are made of andesite and red sandstone, two of the hardest stones found in the region. They are cut with angles so precise, surfaces so flat, and internal geometry so complex that the structure they originally formed has never been successfully reconstructed. Not by the Bolivian government, not by international archaeological teams, not by anyone with a 3D modeling program and the full set of surviving pieces. The site is called Puma Punku. Its builders are called the Tiwanaku. And what they did, or did not do, at 12,800 feet in the Andes, somewhere between the 5th and 10th centuries AD, remains one of the most uncomfortable, unsolved problems in world archaeology. Here is the deal. For 120 years, the mainstream explanation has been the same. The Tiwanaku were a skilled pre-Columbian civilization. They had stone tools, copper implements, abrasive sand, and a lot of time. They quarried these blocks, dragged them to the site using ramps and ropes, and shaped them with handheld chisels until they fit together. Case closed. Except nobody has ever been able to make that explanation actually work. In late 2024, a team from a European Geoarchaeology Institute brought a piece of equipment to Pumapunku that had never been used on the site before. A structured light 3D scanner capable of measuring surface irregularities down to 0 millimeters, 10,000ths of a millimeter. For perspective, that is more precise than the tolerance required for a modern aircraft engine. They ran the scanner across the surfaces of the H-shaped blocks. They scanned the internal grooves. They scanned the corner joints that nobody has ever satisfactorily explained. What they measured is forcing a conversation that mainstream archaeology has been avoiding for decades. Because either the Tiwanaku had access to technology we do not understand, or someone else built Pumapunku before the Tiwanaku arrived. And neither answer fits the story we have been telling ourselves about pre-Columbian South America. To understand why Pumapunku matters, you first need to understand what the Tiwanaku civilization was, and what it was not. The Tiwanaku emerged in the high Andes around 300 AD, centered on the southern shore of Lake Titicaca, the highest navigable lake in the world. At their peak, between roughly 500 and 900 AD, they controlled a territory stretching from the Bolivian Altiplano into parts of modern Peru, Chile, and Argentina. They were not a small, primitive tribe. They were an organized state-level society with sophisticated agriculture, extensive trade networks, and monumental architecture. Their capital city, also called Tiwanaku, may have held 20,000 to 40,000 people, substantial by any ancient standard. They built terraced fields that allowed farming at elevations where crops should not grow. They developed raised field agriculture that increased yields in the thin mountain air. They created distinctive ceramic styles that spread across the central Andes. They carved stone statues that still stand at the site today, including the famous Bennett monolith, over 24 feet tall. The Tiwanaku were real. Their achievements were significant. Nobody disputes this. What people dispute is whether the Tiwanaku could have built Pumapunku, because Pumapunku is different from everything else at the site. The main Tiwanaku complex, located about a quarter-mile from Pumapunku, contains impressive but comprehensible architecture. Stone walls, terraces, temples, construction that is clearly sophisticated, yet fits within the expected capabilities of a Bronze Age civilization. Pumapunku doesn't fit. The blocks at Pumapunku are cut with a precision that appears elsewhere in the ancient world only at sites like the Serapeum of Saqqara in Egypt, or the finest Inca stonework at Cusco and Ollantaytambo. The surfaces are flat to degrees that challenge measurement. The angles are consistent across multiple blocks as if cut from templates. The internal geometries, the grooves, the notches, the interlocking shapes suggest a construction system that no one has been able to reverse engineer. And the material is the problem. The blocks at Pumapunku are primarily made from andesite and red sandstone. Andesite is a volcanic rock that measures 6 to 7 on the Mohs hardness scale. For comparison, copper measures only 3. Steel files measure 6. You cannot effectively cut andesite with copper tools. The tool will wear down faster than the stone. It would take months to produce a single cut, and the result would show the irregular marks of slow, laborious handwork. The surfaces at Pumapunku do not show these marks. They show something else, surfaces so uniform that they appear machine-made. Corners so sharp they could cut paper. grooves so consistent they seem stamped rather than carved. This is the problem that has haunted Puma Punku scholarship for over a century. The craftsmanship exceeds the tools. The precision exceeds the technology. The results exceed the explanation. And nobody has been able to resolve the contradiction. The first Western researcher to seriously study Puma Punku was Arthur Poznański, an Austrian Bolivian engineer and amateur archaeologist who became obsessed with the site in the early 20th century. Poznański spent over 50 years studying Tiwanaku and Puma Punku. He surveyed the ruins, documented the blocks, and developed theories about their construction that mainstream archaeology has never accepted. His most controversial claim involved astronomical alignments. Poznański believed that certain structures at Tiwanaku were oriented toward astronomical events, solstices, equinoxes, and stellar risings, and that by calculating the precession of the Earth's axis, he could date the original construction. His conclusion was simple and startling. The site was built around 15,000 BCE. This date is rejected by virtually all modern archaeologists. Radiocarbon dating of organic materials at the site consistently returns dates between roughly 300 and 900 AD, placing construction firmly within the Tiwanaku period. Poznański's astronomical methodology has been criticized on multiple grounds, and his 15,000 BCE date is considered pseudoscience by the academic establishment. But Poznański's observations about the stonework itself have proven harder to dismiss. He documented the precision of the blocks. He noted the complexity of the joinery. He measured angles and surfaces and recorded the results. And he concluded that the craftsmanship exceeded what Stone Age or Bronze Age technology should have been capable of producing. Modern researchers who have examined the site, including engineers like Christopher Dunn and researchers like Brian Forster, have reached similar conclusions using more sophisticated equipment. The measurements keep showing the same thing. Surface is flat to within thousandths of an inch. Angles consistent across multiple blocks. Internal geometries that repeat with near-identical precision. These are manufacturing tolerances, industrial tolerances. The kind of precision you achieve with power tools, templates, and quality control, not with handheld stones and copper chisels. The mainstream explanation for how the Tiwanaku-shaped andesite involves diorite. Diorite is a hard stone, similar in composition to granite, that measures 6 to 7 on the Mohs scale, roughly equivalent to andesite. Mainstream archaeologists propose that the Tiwanaku used diorite hammerstones to pound away at the andesite, slowly shaping the blocks through endless repetitive percussion. This technique is real. It was used elsewhere in the ancient world, including at the granite quarries of Aswan in Egypt. The unfinished obelisk at Aswan shows clear evidence of diorite pounding, rough surfaces, irregular tool marks, and the slow progress of workers removing material bit by bit. The hypothesis is plausible in theory. The problem is that it does not explain what we actually see at Pumapunku. Diorite pounding produces rough surfaces. It is effective for removing bulk material, but it does not create the polished flat faces found on the Pumapunku blocks. The Tiwanaku would have needed additional finishing techniques, grinding, polishing, and abrasive sanding to achieve the observed results. These finishing techniques exist. Ancient peoples use them. The Egyptians polished granite to a mirror finish using sand and patience. But the Egyptian examples took years, decades possibly. The labor investment was enormous, reserved for the most sacred objects and the most important tombs. At Pumapunku, the precision isn't limited to a few showcase pieces. It appears across hundreds of blocks. The H-shaped blocks, distinctive geometric shapes with complex internal grooves, exhibit identical precision across multiple examples as if produced on an assembly line. This is not what hand finishing looks like. Hand finishing produces variation, slight differences in angle, in flatness, in depth. The hand of the individual craftsman is visible in the work. At Pumapunku, the hand of the craftsman is invisible. What's visible is standardization, manufacturing precision that suggests some method of achieving consistent results across multiple pieces. What method? Nobody knows. The H-blocks are the most disturbing artifacts at Pumapunku. They're called H-blocks because of their shape. Viewed from above, they roughly resemble the letter H with two vertical elements connected by a horizontal crossbar. Each block is made from a single piece of stone carved with a complex geometry of surfaces, grooves, and notches. The blocks are clearly designed to interlock. The shapes are complementary. Protrusions on one block fit into recesses on another. The system was obviously meant to create a stable structure without mortar, the geometry itself holding the pieces in place. But here is the problem. The blocks do not all fit together. Some blocks match, others do not. The dimensions vary slightly from piece to piece, as if different batches were produced to different specifications, or as if the site was never completed, or as if pieces are missing that would make the puzzle complete. Despite 120 years of study, no one has successfully reconstructed what Pumapunku originally looked like. Computer models have been attempted. Physical reconstructions have been proposed. International teams with access to the complete inventory of surviving blocks have tried to solve the puzzle. None have succeeded. Either the structure was so unusual that no recognizable architectural form emerges from the pieces, or a significant portion of the original components are missing, or the blocks were never assembled in the first place. This last possibility is rarely discussed, but it haunts the site. What if Pumapunku was never finished? What if the blocks were manufactured, transported to the site, and then abandoned before assembly? This would explain why the pieces do not fit together in any obvious way. It would explain the variations in dimension. It would explain why the site looks less like a ruined building and more like a workshop floor scattered with components. But it raises another question. Why were they abandoned? The Tiwanaku civilization did not end suddenly. It declined gradually over centuries, eventually fragmenting into smaller polities that were later absorbed by the Inca. There was no catastrophe, no invasion, no dramatic ending that would explain why a massive construction project was left incomplete. Unless the project was not Tiwanaku at all. Unless the Tiwanaku found the blocks already there, already cut, already scattered, and tried to understand what earlier people had built. This hypothesis is heretical to mainstream archaeology. It implies an unknown predecessor civilization. It suggests continuity of presence across time periods that the accepted timeline does not allow. But it would explain the evidence, the precision that exceeds Tiwanaku technology, the unfinished state. The Tiwanaku structures nearby that are clearly less sophisticated. The sense which every visitor to the site reports that two different levels of craftsmanship are present. One extraordinary, one merely impressive. Something does not fit, and the usual explanations do not make it fit. The elevation of Pumapunku is not a minor detail. It is central to understanding why the site is so remarkable. At 12,800 feet, the air contains approximately 40% less oxygen than at sea level. Physical labor is dramatically more difficult. Modern workers at this altitude tire quickly, require more rest, and accomplish less per hour than workers at lower elevations, moving massive stone blocks, some weighing over 100 tons. Under these conditions seems almost impossible. The labor requirements would be enormous. The logistical challenges would be extraordinary. The nearest quarry sources for the andesite blocks are approximately 10 miles away across terrain that includes ravines, slopes, and areas without roads. The red sandstone came from even farther. Some estimates placed the source over 50 miles distant. How did the Tiwanaku move 100-ton blocks across 50 miles of Andean terrain at altitudes where breathing is difficult and physical exertion is exhausting? The standard answer is manpower. Lots of it. Ramps, rollers, ropes, and thousands of workers pulling together. This answer is theoretically possible. Large numbers of people can accomplish remarkable things. The pyramids of Egypt prove that human muscle, properly organized, can move stones of almost any size. But the pyramids were built at sea level with access to the Nile for transport, in a wealthy empire that could command resources from across an entire region. The Tiwanaku were impressive, but they were not Egypt. Their population was smaller. Their resource base was more limited. Their environment was more challenging. And they still would have needed to cut the blocks with precision that exceeds what their technology should have allowed. The elevation does not just make the logistics difficult, it makes the entire project seem impossible for a Bronze Age civilization working with the tools we assume they had. Either the Tiwanaku had capabilities we do not understand, or they did not build Puma Punku. Both possibilities are uncomfortable. The 2024 scanning project approached Pumapunku differently from previous studies. Previous measurements had used hand tools, calipers, straight edges, equipment capable of detecting variations down to perhaps a millimeter. This is precise by everyday standards, but it is not precise enough to characterize the surfaces that researchers were observing. The structured light 3D scanner used in 2024 works by projecting patterns of light onto a surface and analyzing how the patterns deform. By comparing the projected pattern to the observed pattern, the system can calculate surface geometry with extraordinary precision down to 0 millimeters or roughly 1/10 the thickness of a human hair. This technology is used in aerospace and automotive manufacturing to verify that components meet engineering specifications. It is the kind of equipment you use when tolerances actually matter, when the difference between a good part and a rejected part might be measured in thousandths of an inch. The team scanned multiple blocks, including several H blocks and several large pieces with flat surfaces that appeared to be platforms or floor elements. What they measured confirmed what previous researchers had suspected, but could not prove with certainty. The surfaces are flat to within 0 millimeters across spans of several feet. This is not approximately flat. This is not visually flat. This is engineering flat. The kind of flatness you achieve with precision grinding machines or surface plates, not with hand tools and abrasive sand. The internal corners of the H blocks meet at angles that deviate from 90 degrees by less than 0 degrees. This is precision that modern machinists would recognize. The kind of precision you specify when parts need to fit together without gaps or wobble. The grooves cut into the block surfaces maintain consistent depth to within 0 millimeters across their entire length. The walls of the grooves are parallel. The floors of the grooves are flat. These measurements do not match what stone tools and manual labor produce. They match what machine tools and industrial processes produce. The researchers were careful in how they presented their findings. They documented the measurements without claiming to know how the precision was achieved. They noted that the results were anomalous without proposing explanations. But the data speaks for itself. Either the Tiwanaku developed manufacturing techniques far more sophisticated than anything archaeology has documented, or the standard explanation for Pumapunku is wrong. There is no third option. The question of who built Pumapunku opens onto larger questions about pre-Columbian civilization in the Americas. The mainstream timeline is familiar. Humans crossed from Asia to the Americas via the Bering Land Bridge during the last ice age, approximately 15,000 to 20,000 years ago. They spread gradually southward, reaching South America perhaps 12,000 to 14,000 years ago. Agriculture developed independently in the Americas, leading to complex civilizations like the Olmec, Maya, Aztec, and Inca. This timeline leaves limited room for unknown predecessor civilizations. The first complex societies in the Andes, the Norte Chico or Corral Soup civilization, emerged around 3000 BCE. Before that, the archaeological record shows hunter-gatherers and early farmers, not sophisticated engineers, but the timeline keeps being revised. Recent discoveries at sites like Monte Verde in Chile suggest human presence in South America as early as 18,500 years ago, earlier than previously accepted. Footprints discovered at White Sands in New Mexico in 2021 have been dated to over 21,000 years ago, pushing back the timeline of human presence in the Americas by millennia. The question is not whether the timeline might be wrong. The question is how wrong it might be. If humans arrived in the Americas earlier than we thought, they had more time to develop. If they had more time to develop, more complex achievements become possible. If more complex achievements are possible, sites like Pumapunku begin to make a different kind of sense. This is not proof of lost civilizations, it is context. The revision of timelines opens possibilities that the old, rigid chronology closed off. Arthur Poznański's 15,000 BCE date for Tiwanaku is almost certainly wrong. His methodology was flawed, and radiocarbon dating contradicts his conclusions. But what if his intuition was partially correct? What if the site contains layers, with later Tiwanaku construction built on top of earlier foundations? What if the precision stonework at Puma Punku represents an earlier phase of construction that the Tiwanaku inherited rather than created? This hypothesis would explain the variation in craftsmanship visible at the site. It would explain why Puma Punku seems different from the main Tiwanaku complex. It would explain why the blocks appear unfinished, perhaps because the Tiwanaku were attempting to continue a project they did not fully understand. It remains a hypothesis. There is no direct evidence of pre-Tiwanaku construction at the site. Radiocarbon dating does not support extremely ancient dates, but the precision measurements keep pointing toward capabilities that the Tiwanaku should not have possessed. Something happened at Pumapunku that the standard narrative does not explain. The site today is a UNESCO World Heritage location, protected by the Bolivian government and studied by international teams. But protected may be a generous term. Over the centuries, Pumapunku has been looted, vandalized, and dismantled. The Spanish colonizers used blocks from the site as building material. Local farmers carted away stones for construction projects. Earthquakes toppled structures and scattered components across the plateau. What we see today is not what the original builders created. It is a debris field, a puzzle with missing pieces, a ruin of a ruin. The original structure or structures may have been far more impressive than the scattered blocks suggest. The H blocks may have fit together in ways we cannot reconstruct because too many pieces are gone. The precision that survives may be only a fraction of the precision that originally existed. This makes analysis difficult. We are studying fragments, not wholes. We are measuring survivors, not originals. The conclusions we draw are necessarily limited by the evidence that remains. But even the fragments are extraordinary. Even the survivors display precision that challenges explanation. Even what little remains points toward capabilities that the standard model of Tiwanaku technology cannot account for. The debates will continue. Mainstream archaeology will continue to propose conventional explanations. Skilled craftsmen, patient labor, techniques that have been lost, methods that do not require anything beyond human hands and simple tools. Alternative researchers will continue to point to the measurements. Surfaces too flat for handwork, angles too precise for manual tools, standardization too consistent for individual craftsmanship. Both sides will talk past each other because both sides are looking at the same evidence and drawing incompatible conclusions. The evidence will not change. The blocks are what they are. The measurements are what they are. What might change is our understanding of what is possible. The history of archaeology is a history of underestimation. Every generation believes it has reached the limits of what ancient peoples could achieve, and every generation is proven wrong by new discoveries. The Maya could not have built their cities in the jungle until LiDAR revealed cities larger than we imagined. The Egyptians could not have achieved precision in their stonework until engineers measured tolerances that challenged modern replication. The Greeks could not have built mechanical computers until the Antikythera mechanism emerged from the sea. At every step, ancient peoples turn out to have been more capable than scholars assumed. Pumapunku may be the next step, not proof of aliens or lost continents or mystical energy, proof of human capability that we have systematically underestimated. Proof that people working with materials and methods we do not fully understand achieved results that we can barely explain. The Tiwanaku, or whoever came before them, looked up at the stars from 12,800 feet above sea level. They cut stone with precision that matches industrial standards. They created blocks that fit together in ways we cannot reconstruct. They did all of this in thin mountain air, with limited resources, against every obstacle that their environment placed in their way. And then they left. The site was abandoned. The structures were never completed or were disassembled so thoroughly that completion is no longer visible. The knowledge that created Pumapunku was not passed down. By the time the Spanish arrived, even the Inca did not know who had built the stone monuments on the Altiplano. The Inca attributed the construction to the gods. They may have been closer to the truth than they realized, not because gods literally built Pumapunku, but because whoever did build it possessed capabilities so far beyond their own that the difference seemed divine. We are still trying to measure that difference. The 2024 scans quantified it with unprecedented precision. But quantifying is not the same as understanding. We know how flat the surfaces are. We do not know how they were made flat. We know how precise the angles are. We do not know how they were cut. We know what the blocks look like. We do not know what structure they were meant to form. The measurements are in. The mystery remains. Pumapunku sits on its windswept plateau, 12,800 feet above sea level, keeping its secrets. The blocks do not explain themselves. The stones do not speak. And the people who cut them, whoever they were, whenever they lived, whatever tools they used, left no record, no instruction, no explanation, just the work itself. Precise, impossible, silent. Waiting for someone to finally understand what they achieved and how they achieved it. We are still waiting, and the stones are still there, scattered across the Bolivian Altiplano, asking questions that 120 years of archaeology has failed to answer. What was Pumapunku? Who really built it? And what did they know that we have forgotten?